Welcome to another session. My name is Dimitris Tosidis and I'm mentor at Audacity. So today I'm going to speak about computer networks, and this is an introduction to computer networking and for the cloud computing courses and for the network courses in general. So let's see my presentation. So as I said before, it is about introduction to computer networking, and my name is Dimitris Tosidis for the computer networks course. So this presentation has three main parts. The first part is the network communication model. So this is how we describe the model that helps to transmit data across the internet and across the network. So I'm going to say what is this model and how it takes place for communication. The second one is the routing. So how the routing takes place inside the internet, how the information is routed inside the internet and inside the networks, and how it is received from the devices. And the third part is about the domain name system requests. So how a request of the DNS server takes place, if you have heard about DNS servers. So in general, how we have domains inside the internet, inside the networks, and how the requests are made, and how we reach a website, for example. Let's go to the first slide. So according to the model, we have a protocol stack. So the information is transmitted inside the internet in the form of a packet or in the form of a message, let's say. So a PC sends messages across the internet to other devices. And there are some protocols that are used for that. We got some protocols like HTTP. So the first protocol is about the applications. So the HTTP is a protocol that the application is can be seen from the users. We got the TCP protocol, which is the transmission protocol. It assures the reliability of the transmission and so on. The other one is the UDP, for example. The third protocol is the IP protocol, the internet protocol. This gives the specific addresses to the devices, and with these addresses can be sent information from each other. And the fourth protocol that is written here is the Ethernet protocol. It's about how the physical devices are sending. It's between the physical devices. It's, for example, if it is Ethernet or if it's a Wi-Fi. So this is a protocol that it has to do with the signals and the bitwise information. So how the Ethernet, through the Ethernet connection, for example, a message is sent after that to the internet or to the other networks and to the other devices and so on. So these are the four protocols that are consisting the protocol stack, which are help us to send packets information from one device to the other in the whole world. Let's go to the second slide. So the second slide is about all the layers. So before that, we got four protocols, but it's not only that. The seventh layer is the application layer, which has the HTTP protocol, and it's about the applications and what we see in our screens. The sixth layer is the presentation layer. This is about the HTML, the formation of the data. The fifth layer is the session layer. So this layer has to do with the SSL protocols, with the TLS protocols, and so on, security of the sessions and so on. And the fourth layer is about the transport layer. So again, it's about the TCP and UDP, how the data are transmitted through inside the communication. And the third layer is the network layer. This is about the IP addresses, the IP protocol. So in this layer, every device has an IP, and from the information is going from IP to IP. The second layer is the data link layer, in which we are seeing not IPs anymore, but MAC addresses. So here the communication is between switches. So the switch is seeing the MAC address and it's directing the information to the packet to the right device. And the first layer, which is above all the other layers, is the physical layer, which here is again the Ethernet layer, the Ethernet protocol, and so on. So how the data is transmitted inside the wires and so on, signals and so on. All these 7 layers are inside the IS model, and all these are included inside the communication inside a network. Okay, so how does this happen? How all these 7 layers are going inside our communication? The packet travels through the TCP stack, for example, like this. Okay, if it is TCP, if it is UDP, something like that again. So there is a sending host and the receiving host. So what's going on with the sending host? So we got the application layer again here, which has the packet, which is the login host. Okay, this is the information that it has about the login page, for example, of the website. After that, this goes inside the TCP segment, which is in the transport layer, which this gives us the TCP or the UDP protocol. And the sending is put in here if we want to send the packet with the TCP or UDP and so on. The second layer is the internet layer. Here is the IP of the sending host, and the TCP segment going inside the IP datagram, which has the IP. The next layer is the data link layer where there is a frame, and the IP datagram is going inside the frame. And here is the MAC address, which is shown in this on this frame. After that is another frame which is a bit bigger, as you can see here, which has to do with the signals, if it is through Ethernet, through Wi-Fi, and so on. So this is a physical network layer. So all this is going inside the other one in every next level, in every next layer. And this is encapsulation. So the information is encapsulated again and again in every layer. And after that, it's going through the network media to the receiving host. And what does the receiving host? Actually, it does the decapsulation. So here it gets a frame in the physical network layer. After that, from the frame, it encapsulates it and it gets another frame which has a MAC address. After that, again, it takes the IP datagram, and after that, it is a segment, and at the end receives the request for the login. Okay, so this is how the packets are going through the internet, and from the sending to the receiving host with encapsulation and decapsulation of the information. So this is taken from the Oracle Corporation. Okay, how does this happens? How this is actually done? Can be done. So this is a simple diagram of the Ethernet packet. So you got at first the user data. The user data is encapsulated inside the next layer. You get here the application header, which shows the application in the transport layer. After that, in the network layer, already the information, the application data has the TCP header. It shows in the if it is a TCP or UDP. And this is a TCP segment. As you can see, it's a bit longer than the previous one. And after that, in the link layer, we put also the IP address is also put from the network layer, which shows the IP. So we got here application data, TCP header, and IP header in front of that. So we have another one more header. And here we got the IP datagram, which is a bit longer than the TCP segment. This is in the what we get in the link layer. And at the end is the Ethernet layer, which we put also another header here, which is Ethernet or frame header. Okay, and we see here the number of the bits of every header. We got at the end the Ethernet frame, and of course there is another Ethernet frame here. So at the end we got from 46 to 1050 bytes at the end the whole length of the information and of the Ethernet frame. And as you can see here, this is the comprehensive, the corresponding layers, application, TCP, IP, Ethernet, driver, and so on. So this is how the encapsulation takes place. So we have the user data, and we put headers again and again in this layer. So the message, the information is encapsulated as a message, and at the end we got this whole Ethernet frame, which is sent through the internet. Let's go to the next slide. So we have seen the model and how the information is encapsulated and is sent through the internet, but how does this take place? Of course, it takes place with some addresses, which are the IP addresses, as I said before. So we got here the network addressing, which takes place with the IP addresses, and every device has its own IP address. So, for example, as you can see here, this A device has this address 223.1.1.1. This is the IP address. This is 8-bit information in the decimal form. And as you can see here, this is unique for this device. The device B has another IP address like 223.1.1.2, and this device 3 has another IP address 223.1.1.3. As you can see here, there are some similarities. So the first three numbers are the same. This is because they are belonging, all these three devices are belonging to a LAN, to the LAN 1, which is the local area network. As you can see here, and you understand, we got a router here, which routes the information, the packets, and it routes here inside some to some LANs. Okay, so the network is consisted from some LANs, which are help us to distribute the information inside some local networks. And every network has its own address here. For example, this LAN 1 has 223.1.1. Okay, so every 223.1.1 is going to this LAN. This every 223.1.2 describes this LAN, and so on. And 223.1.3 is describing this. So when information is coming here and you have the first three numbers of the IP address, it's going to the right line, and after that to the right device. So this is how the addressing takes place inside a network after the router. Of course, the router gets inbound information from the internet and it distributes like that, but how the information is coming from the internet and how it's going to the internet, so how the inbound and outbound information is coming and going, it's like this. So we don't have always, as you imagine, we don't have always one IP for the router. The internet is very big, so the addresses we have millions of billions of addresses so far. So we cannot have for every single device in the whole world only an IP. So we have some kind of network address translation. So we got the translation here from the network addresses. As you can see here again, we got these devices. And this time we don't have any LAN, or we may have a LAN that is described from 192.168.100. And after that, there are these IPs for every device. And this, for example, this device wants to fetch this website. So www.yahoo.com. Okay, the step one is that the source is the actual device, which is this IP, as you can see here, and this is the port that is going to receive the information. And the destination of this website is this. So 209.131.36.158. Okay, and the port is the 80 port, which is a very famous HTTP port. So this is the first step. It's going here to the router, and the router makes the translation in order to find the right website. So the router uses this NAT translation table, which has here the address of the device, which is a private IP address and port. And this is I'm sorry, this is the device yes of the this is the IP of the device and the actual port. And here it has the router another IP. So we got here the IP 192.168.1.1. Of course, this site is the private site, and it is translated to the public site, which is another IP that it's going to be translated, and it's going to be replaced the private IP, and this will be from now on the IP address that is going to be used. So here, this address is translated to this address, which is the public IP, and this is going to replace the source of the routing. So as you can see here, it is this address is replaced from this address, and now the source of it is this address from 145.12.131.7 with this port, and the destination is again the same, which is the destination of the website www.yahoo.com. So in this manner, all the requests are taking place inside the whole internet and inside of the network. So the routers have these translation tables, and from the private IPs, we are going to the public IPs. So we got this private here, and after that we change the source IP, and it's going to the whole world to find any website inside the internet. Otherwise, it wouldn't be possible to have so many websites and without this IP translation. And it would also take much time because one service from the other have a lot of distance. Okay, let's see the next slide. So how the requests can be done, how the requests are taking place inside the whole internet. The requests are taking place with the domain name system. So the whole internet is full of IPs. Of course, you cannot, nobody can remember all the IPs. And of course, we got these IP translations according to the network. Okay, so what can be done is that we got the domain name system, which I'm gonna show next. And right now, I'm gonna show here how the request takes place. So we got the typical external here DNS request, domain name system request. So we got here the user which wants to see a website. So he has a query here with the domain to the DNS server with the website. And here, as you can see, there is not the website is not cached. So we're going to search for that inside the internet and inside the several servers. So at first, there's the first request for the root DNS in order to make the domain. So the root DNS is gonna send back the last piece of the domain. So you're gonna send the .com or .org or .de according to the root of the domain. So we got the request. The root DNS takes the request with the domain name, and it sends back the response, which is the information for the last part of the domain. After that, this is cached, and after that, we're gonna send the second request. So the second request is gonna be, this is a non-authoritative and recursive DNS server because it looks around all this domain name parts. Okay, so the second one is going to be to search again recursively about the right top-level DNS, which gives us the top-level domain name, which is the middle part of the URL. So it sends a request, it takes the response with the second part of the domain name, and at the end, this is also cached inside our PC, this information, and at the end, the last request is sent to the authoritative DNS server, which restores the right URL. So we got the first two parts from the other DNS servers, the root and the top level, and at the end we get the whole URL from authoritative DNS server. Get it back, we cached it, it put in the cache of the computer and is ready for the next time. And the whole thing is going to be sent back to the user as a DNS response. And this is how every request. So when you want to see a website, you type something on the web browser, and the whole thing is taking place inside the internet. And it's going to search all the servers recursively your browser in order to find the right website and for you to see the content of the website. Okay, let's go out a bit. And let's see at the end, this illustrates how the URLs are made. So as we can see, there is according to the URL addresses, there are some hierarchy, and also the names, the domain names are distributed, just like in the previous example. So distributed to around the internet to some servers, and also has some hierarchy. So at first we got the root server, which root server is the first request and gives back the first part, the last part, but the most specific part of the URL. And after that, we got, for example, com, org, edu, and so on. So the next request is going to be to the DNS server, to the top level domain server, and it's gonna give us back the next part. So as you can see here, this is yahoo.com or amazon.com or ieee.org or sjsu.edu or mit.edu and so on. So it gives back the top level domain name, the second server, as you can see here, and this is the hierarchy. And at the end, the next step is the authoritative servers, so the last layer, which is under all this, under all the other layers. So according to the previous things, there are some more references in order to read more about them. This is the Cisco Press, the communication principles, if you want to read more about that. Data encapsulation in TCP/IP protocol stack from the Oracle documentation, packet switching from the computer science wiki, network addressing from the Java point. And of course, the Wikipedia has a lot of nice information and essential information, such as network address translation. And this Liku Zeleke has a very nice website with what is DNS hierarchy and so on. So at last, I would like to show to you some examples of what's going on in action. I'm gonna share with you. This is a tool which is a very nice tool that monitors the traffic inside our networks, inside the networks that my PC right now is communicated. Let's see what's the traffic on my Wi-Fi. Now the monitoring tool is grabbing all these packets. So again and again, I'm building these packets. I have also the website of the Audacity opened. So I'm grabbing from the browser again all of these packets. These packets are enough. So I would like to stop it in order to not get any more, I think. Let me one moment to see. Yeah. Okay, as you can see here, I got a lot of packages. This is the number of the packages. This is the time that the packets are grabbed. So it is around 23 seconds that I grab this package. This is the source IP that the packet this is the destination IP that the packet is going. This is the protocol. And this is the length, how big the packet is, and some more information. As you can see here, there is also two other boxes. This box illustrates the information in the layers that we can see. And this is this information in a hexadecimal form. Okay. So let's see here what's going on. This is the frame that we have talked before and I have shown before. So this is the frame, how many bytes on wire and so on. This is the 7th level. Okay, the Ethernet protocol. And according to that, this is the 6th level. So we got also the Ethernet right now. Here we can see this is the MAC address of the source. This is the MAC address of the destination. This is the 5th floor, the TCP, the Internet Protocol, which you can see here. It is a Internet Protocol version 4, the form of the package. This is the source IP. This is the destination IP. This is the TCP protocol, as you can see here. And here is it's shown the IP, the open port, the source port, and this is the destination port. And as you can see here, this is the application, the transport layer security. Okay, as you can see here, the third port. Okay. As you can see here, there are some more information about the application data, HTTP protocol, and so on. So this is according to that the first protocol. This is the actual data. Okay. So let's see some a specific packet. That, for example, here you can see this information. You can see that also this information here, but more specifically and more detailed. As you can see here, this is a number of the bytes on the wire, number of the bytes that are captured, and so on. This is here again the MAC addresses. This is here again the protocol, which is IPv4 IPs. It is here is a UDP protocol. it's the alternative protocol of the TCP. There are also another protocol, but the most famous protocols is the UDP and the TCP, according to the communication that the hosts do have. And at the end, this is the domain name system query. So as I said before about the DNS requests and how we can see a website, we send a request and we get a response. So this is in the frame of a query, as you can see here. So there is a query inside that. So we consist a query in which we ask something, okay, and we send it with a request. As you can see here, this is the this is a DNS query, and this is the DNS query response. This is the response, and this is the request. So as you can see here, this is the response here, the request here. So we got here the query, here's the transaction, standard query is the flag, and this is the actual query, which we sent. Okay, this is for the Skype.com. This is a type A, so because it is an IPv4, and there are a big range of hosts inside that, class in, and so on. This is the length of the data again. As you can see here, this is the hexadecimal form, and so on. And here is the response. So let's see the response in 111. This is the response, as you can see here. As you can see here again, this is the response of the above as it was written down. So this is again in the domain layer, in the application layer, the response. So here it is standard query response, no error. As you can see here, these are the queries. Again, this is the query that was before, and this is the answers. As you can see here, these are the three answers that we get from this request. And as you can see here, this is the length of the arguments and so on. Let's see also the other responses. Canonical name for an alias, in name. Okay, these are the name of the domains and the data that it sent.